What's up, everybody? Today we're going to be talking about LeetCode problem 1488, avoid flood in the city. So reading this problem was kind of confusing, to be honest, and I didn't understand it for like the first minute that I was reading it. So if that's why you're here, hopefully I can help explain it, and you can solve it yourself or what have you. But so let's sort of go over this problem. We're given an array, okay, and in this array we're given actually two types of things, even though they say they only give us integers. They give us one set of integers, which are natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, etc., that tell you on that index day, for example, here, index 1, it's going to rain on lake number 2. Alternatively, if there's a 0 in the array we're given, on day 2, 0, 1, 2, it doesn't rain at all. It doesn't rain on lake 0. It doesn't rain at all. And what we have to do is on days where it doesn't rain, choose a lake to dry such that a lake doesn't get rained on that already has water in it. For example, there's no solution to this problem. It rains on lake 10 on the first day, it rains on lake 20, and then it rains on lake 20 again. There's no chance to dry the lake. Okay? Alternatively, for this problem, there is a solution. It rains on lake 1, rains on lake 2. We dry lake 1 or 2 here, it doesn't really matter. And then it rains on lake 1 and 2, and then it's over. Doesn't matter. No lake flooded because rain didn't rain on a lake that was already there. Already had water in it. Okay? So let's sort of move into the problem. So let's just get right into the algorithm and sort of what the intuition is behind this problem. The intuition is basically we want to be drying lakes that are coming up soon. Okay? If we had a lake that was rained on day 0, and it wasn't going to have rain again for, a billion days or a billion years, we wouldn't really care that much, right? So we want to be able to know what day is coming up next. And this is typically, when you want to know some ordering in the list, you can accomplish that with a pre-processing step in linear time, right? We can do one pass over the list. And what we're going to do is we're going to create this set, or this hash, I guess, hash table. And in this, we're going to record where we see certain lakes. So lake number 9, we see at index 0 and 7. Lake number 2, we see at index 1, 3, and 6. And this is going to allow us to, when we're moving through the list again for the second time, when we're trying to figure out which lakes to dry on non-rainy days, we're going to be able to look at this and sort of analyze it. So the basic idea is we want to keep two data structures. The first thing is going to be a set that's going to tell us which lakes are full. And that's pretty intuitive, right? So on day 1, we'll see 9. We'll put 9 in this set. Okay, that sounds useful. And this is useful because if this were a 9, right, we would be immediately able to tell that there's no solution and we just return the empty array, right? The second thing we need to keep is the next best index to dry. Let's say we fill 2 and 9 into the full lakes. When we get to this dry day, you can probably see immediately, well, we need to dry 2, right? Because 2 is right after it. So we need some data structure, some ordering of 2 and 9, such that we know 2 is coming up next. So long story short, we're going to use a min heap. In general, whenever you hear something like, we need the next thing in the list, or we need the next best thing, a heap is going to be your go-to, right? A heap is going to be sort of what you're really most commonly going to use to solve problems like this. and we're going to stuff indices into this heap. We're going to stuff the next index of that lake. So when we start and we add 9 in, we're going to cross out 0. We already saw index 0, and we're going to add 7 into our min heap. So if this were a dry day here, we would pop off the min heap and we would dry 7. But we get to day 1, we see the 2, we cross off the index we're at, we add in the next index. It's a 3. Well, that's coming up sooner than 7, so we'll put it in the min heap and it'll reorganize itself, a heapify, right? And 3 will be on the top. And once we get to day 2, we will pop off from our min heap. So we'll pop off 3, this will go away, right? And we'll say, okay, what's at index 3, right? Index 3 is coming up next, right? This is the next sort of lake that's full that's coming up next. Well, we look in this array, well, 2 is at 3, so we put 2 in our solution array, right? And every day that has a lake that it's raining on is like a -1, just by definition of the problem, right? This is going to get a little bit messy, but we can imagine some separating line there. And so we'll get to 3, and eventually this gets removed on day 3, or removed on day 2, and then it gets re-added on day 3. And we look up here and we go, oh, okay, 6 is the next index, so we add 6 into this min heap, and we get to day number 4 and we pop 6 off the min heap and we put it here. And then we get to day 5 and we pop 7 off the min heap and we put it here. And while we're doing this also, we're removing stuff from the full lakes as we're clearing it up. Sorry, these aren't 6 and 7. These are the value at that index. So when we popped off here, it was 6. Well, value 2 is at index 6, so we'd put a 2 here, right? And then value 9 is at index 7, so we would put a 9 here. And that makes a little bit more sense now that I wrote it correctly. And this is sort of our solution. And you can see that if you sort of just chose to fill in a 9 here, you would run into trouble, because once you got to day 3, it would rain on lake number 2. I'm not going to show the code anymore in the videos. The code is going to be below in the comments. If you sort of liked the pace of this and prefer this instead, that this is pretty much going to be the sort of model moving forward. Going to be sort of less sort of talking and more sort of just jumping right in. So if you want to see more videos, like, subscribe. Thanks. Hope to see you in the next one.